Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, doctor. How are you today? I hope you are in very good condition in the current situation right now. Me, myself, Alhamdulillah, I'm still in a good condition, still healthy and still fasting. And before we start, I would like to introduce myself. My name is Fikran Shah Muhammad Nasir, and my matric number is A19EC0237. Hereby, I would like to explain to you about my lab project that conducted by our lecturer in subject computer organization and architecture. This is my second lab. What we discuss in this fact 2, we discuss about arithmetic equation and operation in assembly language. The implementation of arithmetic equation and operation in assembly language. So as you can see in the screen, we have this is my lab sheet for the lab. So our lecturer already give us some numbers of case to do in our assembly language. So for this project, we use an application which is Microsoft. Me myself, I use Microsoft Visual Studio 2010. So basically, this is how the interface of the application. And so we're gonna start from number 1. We had kind of project here, a program. This for first I'll explain. There are two main parts for assembly language programming. There is .data for us to put our data name and basically like variable, and we put the value of our variable there. And .code is basically how we want to do our program there. So I would like to copy paste this program to my assembly language, my Microsoft Studio. So yes. So before we start, I would like to explain in the part of code, we had move, we had exchange. So move is basically we assign the value, we move our, like this one, move EX, comma, var1, we move our value from var1 to the register EX. So the right memory is basically our source, and the left one is our destination. So before we run this, this one up. To run this program, we're gonna start by pressing start without debugging, or control plus F5. So it's gonna appear this one. Yes. So we're gonna clearly start, and then after that we use the step over. There you go. And so here we had a table for autos. This is basically the value of line from this arrow. So we had AX and var1, but this AX is not yet been been processed. We need to move the arrow to the down of it, to the bottom of it, so that we can see the result. So we're gonna press 10. So we'll see there is a red color in the value of EX, means that there is some change in the value of EX. So the value of EX is become 1 because we already move from var1, which is the value is 1. We move the value of it to AX, so the AX become 1. And also in autos, we can use another display. Here is the hexadecimal value, which is actually normal to use. So basically like keep doing it. I press another F10 and here's another one, move BX, comma var2. So the var2 is 9. So we assign that value to BX. So the BX become 9, or in hexadecimal is 0009. And we press again F10. Here's the function is exchange EX, BX. Exchange is basically as like what exchange means. We exchange the value between these two register EX and BX. So the EX become 09. Before it was 01, and the BX become from 09 to 01. Then we go to another line. We have move var1, EX. So we move from before we move from memory to register. Now we move from we try to move from register to memory. So here we got the var1 become same as the AX, which is 09. And then the same as move var2, the the var2 is assigned with the BX, which is 01. Another program. So we're gonna go to number 3. I would like to copy paste this one. So we got this data var1 5, var2 equal to 10, var3 20, var4 not assigned yet. Oh, so we have this one also, the word double word, or the size of our value. You got double words means the word means double word. So the size of it, one word is basically 16 bit. So for double word we have 32 bits. So to start this, we should stop debugging from the first program, and then we start without debugging too. And yeah, I press F10. In this one we haven't yet see the real value from this function move BX and var1. So I'm gonna press another F10 to see the value. So same things, we move the value from var1 to EX. So the var1 is 5. So the value of EX should be 005, same thing. And then we press another F10. This is malfunction means multiplication. So for mul, we basically write our multiplicand at one line, and then the multiplier will be at the top of it. So we had mul var2 as a multiplicand. So the multiplier will be at the top of it, which is from EX. So the var2 is here in hexa is A. A means in decimal is 10. So 10. So 10 is multiplied by the, oh sorry, the multiplicand is the EX one. Multiplier is from the same line with the mul function. So it multiplied by EX. The EX before was 5. So here in decimal we got 50 for the EX. And then we press another F10. This we add from part 3 to add to the EX, which is 50. So part 3 is 20, so we got the EX 70. And here it is the function means decrement. Decrement basically means that we should minus 1 the value from the EX. So the EX before was 70. We assign it with the decrement function, so we got the value of EX is 69. And then another F10. Another F10. We assign the value of EX to variable 4. So the variable 4 becomes 69. So here's for the last number. This is for number, I think I will take the number 5. So here's number 5. Stop debugging. Then stop debugging. Okay. So continue to last number, which is number 5. So in this number, we need to make our program from the equation of this one. A equals to B plus C in parentheses multiplied by D minus E. So in my program, first we assign the val. We already had the data variable. We had the val A not initialized yet, and val B equals to 12, val C to 4, var D to 20, and var E to equals to 10. So what we need to do is we assign we need the assign from value from val B to register. So we're gonna use move EX, comma val B. Why we need to do this? Why we need to send the value from the memory to the register? Because we cannot do operation from memory to memory. That will cause an error. So we need to assign with register. And then next, so we're gonna end this. We assign, so the x is equal to 12 2. And then we add the EX with the file C, which is 4. So 12 plus 4 is 16. We got the EX 16. And then we move the variable D to register BX. So the BX becomes 20. So then we subtract the BX with the var E, which is 10. So we got the dx equals to 10. And then we multiplied. So the it will start from the multiplicand will be the ex. So ex times bx becomes 160. 16 multiplied by 10, and then we assign the value from the ex to the value, and that's all. So my reflection about this lab is I'm able to learn new things about especially a programming language which name is assembly language, and I'll able to understand how important is assembly language in our next future. If we want to make some program with a machine on it, with using our PC, I mean, assembly main task is to make an ease for us, the user, to understand about the the language of the machine, the CPU itself, and vice versa. So assembly is basically like a bridge for us, the user, and the machine itself. And I think I would like to share my uh, process how to work on this project. So I think it's actually faced some kind of problems. Mm, not some, I think many problems due to because of this condition, this MCO, and there still we had pandemic. We still have pandemic in the world. So being not being able in the class is made some difficult here. I need to learn by myself. If I want to ask for friends, I need to call them, not just talk to them. And yeah, that's I'm actually all alone here in this project. So, but finally, I'm able to finish it. So I think that's all. Thank you, doctor, and I hope all of us still all of us will be able to manage all of this situation, keep healthy, and wassalamualaikum warahmatullahi wabarakatuh.